Good day, boys and girls. Thank you for coming back. Now, today we are going to touch on something on radioactivity. This is the final chapter in Form 5. And the subtopic that I'm going to teach is on half-life. Good news for you. Half-life is the easiest topic in the whole world. It's the easiest. Anybody can understand it. That's why I'm giving you this quote. The physics is as simple as ABC. Alright, after this lesson, I'm sure all of you will say, yes sir, I agree with you wholeheartedly. Just a quick reminder again, when we revise physics, it is not just reading from page 1 to page 400. No, that way of revision would not be effective. What you must do is to keep on answering questions. So even as I revise with you on half-life, I am taking a question from 2006. And this is the question from paper 1, number 49. It reads, the initial mass of radioactive element is 10 grams, and its half-life is 6 days. Which of the following statements about the mass of the radioactive element is true? So to understand this, we basically need to understand the definition of half-life. It is very important. Now, in terms of the mass of a radioactive element or substance, half-life is actually the time taken for half of the mass to disintegrate. That's all. So what do I mean by this? That the easiest way would be to look at it and to try to understand it from a picture point of view. Okay, let me bring you to the calculation now. Now let me just explain by giving you another example first, before we go to the question. So let's say I start with an object, or rather a substance, radioactive substance. I start with 100 grams. Let's say its half-life is 2 days. So after 2 days, what will happen? According to the definition, after 2 days, which is the half-life, half of 100 grams would have decayed, disintegrated. So how much is left? So you can tell me it's 50 grams. I draw a smaller cube. 50 grams. So now another half-life has gone. 2 days. After another 2 days, how much is left? Half of 50 grams gone. So I can even see, I can even read your lips. Alright? You're saying 25. Very good. 25 grams. And so on and so forth. So which means that if I start off with 100 grams of a radioactive substance, after 4 days, I get 25 grams left. The half-life is 2 days. Half-life 2 days. After 2 days, I get 50 grams. Uncle, where's the formula? Good news, no formula. No need to use formula. Just understand the concept and then you use a diagram and draw it. Uncle, in examination, can draw diagrams or not? Can. Because your diagrams basically explains to your teacher that you understand the concepts. So you draw diagrams to explain. Very good. Now you say, I understand. Let's go back to the question. Let's look. Initial mass of a radioactive element is 10 grams. Alright, so now we start with 10 grams. We start with 10 grams. I just draw a box, okay? So we start with 10 grams. Half-life, 6 days. So after 6 days, what happens? After 6 days, after 6 days, how many grams left? what would your answer be? After 6 days, it will be 5 grams left. Another 6 days. So simple, the concept. How many grams left? You'll be telling me 2.5 grams. If you look at the question, it has answers before and after the 10 grams. So let us go backwards now. Before we got 10 grams, alright, before we got 10 grams, how many days of half-life? 6 days is the half-life. So 6 days before the 10 grams, how many grams do we get? I'm sure you can tell me it is 20 grams. Okay, check. 20 grams from here. After 6 days, we have 10 grams. Because 6 days is the half-life. Another 6 days before the 20 grams. How many grams would that be? 40. You're telling me it's 40. Very good. This is as easy as ABC. Simple. Don't need calculators, you know, but you must, I'm sorry, it's not 40 days. It is 40 grams. Okay? Now, you must not use mental calculation. I have seen many students, they try to do it in the air, and then they make a mistake. You must draw. Write it down. 6 days, the half-life. 6 days. Alright, let's start all over again. 40 grams. After 6 days, 20 grams. After another 6 days, 10 grams left. After another 6 days, 5 grams left. Another 6 days, 2.5 grams left. Okay? So, this is our working for the question. Let us look at the answer. Alright? What is the answer? A, 6 days earlier, the mass is 20 grams. 6 days earlier, the mass is 20 grams. 6 days earlier, the mass is 20 grams. Is it correct? Yes. And let us check the other answers. 12 days earlier, the mass is 80 grams. 12 days earlier, the mass is... Okay, we started here. Don't forget. 12 days earlier, the mass is 80 grams. So we know that B is the wrong answer. Now I'm going through with you so that we understand the concept as well. Now what about C? 6 days later, mass 2.5 grams. 6 days later, we start here. This is the point we start. 6 days later, it should be 5 grams. So C is the wrong answer. It's good to go through all the answers for revision. So we know that C is wrong, B is wrong, A is correct. Nevertheless, we still want to check. This is wrong, A is correct. 12 days later, the mass is 5 grams. D. 12 days later, what is the mass? 12 days later, the mass is 2.5 grams. So, you know that the answer D is wrong as well. So when you do revision, boys and girls, do it this way, step by step. Even after getting the correct answer, go through the wrong answers and you must understand why the wrong answers are wrong. Alright, let me sum up. Number 1, understand and write down the definition of half-life. Number 2, when you answer questions on half-life, you must write it out, draw the diagrams, sketch it. It's very simple diagrams. And these diagrams actually explain the meaning of it. And from there, you can calculate and you can understand the questions involving half-life. So with that, I would like to say thank you very much for your attention and may God bless you. Bye. See you again next time.